Hello everybody, I'm Shreyam, a CMI alumnus. These are my achievements, and in this video we're going to talk about this problem from ISI 2023. So in this question you have a quadrilateral ABCD whose all the internal angles are less than pi. You draw squares on each of the sides as shown in the figure below, and you create these triangles, and the areas of these triangles are delta 1, delta 2, delta 3 and delta 4, and you have to prove that delta 1 minus delta 2 plus delta 3 minus delta 4 is equal to 0. So the first thing we'll do in this question is we'll simplify what we actually have to prove. So instead of showing this, all we can do is show that delta 1 plus delta 3 is equal to delta 2 plus delta 4. So what we want to prove is that the sum of the areas of these two triangles is equal to the sum of the areas of these two triangles, right? So we'll look at this figure in two different ways. So the first thing you can observe is that given any triangle, the area of the triangle can be written as half the sum of the product of the adjacent sides times the sine of the angle in between those adjacent sides, right? So this is what we'll use for this question. So if I label the angles as alpha 1, alpha 2, alpha 3 and alpha 4, and let's say that the sides of the squares are S1, S2, S3 and S4, then we can write the areas as follows. So delta 1 is just going to be half S1 S4 sine alpha 1. Delta 2 is going to be half S1 S2 sine alpha 2. Delta 3 is going to be half S2 S3 sine alpha 3. And delta 4 is going to be equal to half of S4 S3 sine alpha 4. So this is the first thing. Now observe that these are squares, right? So these two angles are 90 degrees. So this internal angle of the quadrilateral turns out to be nothing but pi minus alpha 1. Similarly, angle B is just going to be pi minus alpha 2, angle C is going to be pi minus alpha 3, angle D is going to be pi minus alpha 4, right? So like I said, we'll look at this figure in two different ways. So the second way we look at the figure is, we draw this diagonal BD. Now, if you look at the area of this triangle ABD, that can be written as, we use the same formula again. So this angle was alpha 1 times these sides are S1 and S4, right? So this is half S1 S4 sine of pi minus alpha 1. But we know that sine of pi minus theta is nothing but sine theta, right? So this turns out to be nothing but S1 S4 sine alpha 1. Similarly, the area of triangle BDC is going to be half. So what are the sides? So we have S2 and S3 sine. Again, it's going to be pi minus alpha 3, so we get alpha 3 here, right? So we get these two results. Similarly, if we draw this diagonal AC, we can say that the area of triangle ABC is nothing but half of 1, 2 sine alpha 2, and area of triangle ACD is equal to half of, this is 3, 4 sine alpha 4. Now, it's very obvious that the sum of the areas of these two triangles should be equal to the sum of the areas of these two triangles, because both of them are equal to the area of the total quadrilateral. So we get the sum of these two quantities should be equal to the sum of these two quantities, right? But if you look carefully, this is delta 1, right? So let's figure out where delta 1 lies in these. So this quantity is delta 1. Similarly, if you look at 2, 3, 2, 3 is nothing but delta 3, right? Similarly, this is delta 2 and this quantity is delta 4. So based on our observation, we can say that delta 2 plus delta 4 is equal to delta 3 plus delta 1, which is precisely what we had to prove in this question. So that is the solution. Thank you for watching the video.